Welcome, episode number 2 on the coordinate geometry. In this episode, we are taking another subtopic, the length of a straight line. So the question could be asked, find the length of the line joining the point A and B, or find the magnitude of the straight line. Find the magnitude of the line A, B, or it could be find the distance of the straight line. So I'm only giving you the 3 wordings or even 4. Find the modulus of a line. The moment they mention any of this, we'll be referring to the same concept that I'll be developing, the distance. So remember we mentioned that the coordinate geometry deals with Cartesian plane. So we are going to learn how to find the distance between the point A and B. In the previous episode, if I have any point here and I want to locate it, I move on the x-axis, that is to the right, then I move up on the y-axis. If I'm looking for the point here, I move from the origin on the x-axis to the right, then I move up. That is how we locate the point. Here you want to find the distance, magnitude, the size, by measurement. What is the distance from here? But we first deal with, since we are dealing with coordinate, which make use of the x-axis and the y-axis, we find the displacement. What is the displacement from the point A? If I am here, what is the displacement? I can displace myself to the right, then I move up to give me the distance between them. So I'm going to say that this is the first x point, let's say x1. Then this is going to be the second x point. Don't forget, if this is the origin, I can have 1, 2, 3. So I am moving away, the number is increasing. So the point here could also be my first y, then the point here is what? My second y. So if I want to find the distance, C is a displacement. What is the distance between x1 and x2? The distance. Let's just imagine that I am using 1, 2, 3. What is the distance between x1, x2? Moving from 1 to 2, what is the distance? I guess if they are of the same dimension, we can say that this is 1 unit, 2 unit. So the unit or the distance between x1 and x2 is just 2. So I am moving 1 unit, then 2. How do I get 2? I can say that 3 minus 1 will also give me 2. So the distance here could be determined as x2 minus what? x1. Moving from the point A to the displacement below the B will be x2, x1. Now, the same way, if I am labeling here 1, 2, 3, 4, and 5, I can ask myself, what is the displacement all the way from A, which is the y1, to 1, 2, 3, 4, 5. What is the displacement here? What is the unit, the size that I moved? I moved 1 unit, 2, 3, 4. Or better still, take the 5 minus 1, which will still give us what? 4. So I can say that the displacement from here will be y2, 5 minus y1. So here will also be y2 minus what? y1. And you can see clearly that this is a right angle triangle. Borrowing in the concept of Pythagoras theorem, we can say that by the Pythagoras theorem, we know that c squared equals to a squared plus what? B squared. The c squared is the longest side, which is the hypotenuse. In this case, that's the distance we are looking for. AB, the length between the AB. So I can say that if I'm looking for the length of AB, we use this to indicate the length or the magnitude of the line AB. So you're looking for the magnitude, the modulus, the distance. We use this. So this is going to be squared, since this represents C. The A and B can be of any size, since there is no angle introduced apart from the 90 degrees. So here could be your adjacent, here could be your opposite. Any of them can be. So A can be anywhere So I can pick my x2 minus x1 to be my a, and the a is squared. I can pick the other side, which is y2 minus y1, which is also squared. The question says we are looking for distance, not a distance squared. So we can be able to find the square root of both sides, meaning the square root of the magnitude of AB all square equals to the square root of x2 minus x1 all square, y2 minus y1 all square. So you can see that the square and the square root will cancel. So therefore, the magnitude is just going to be the square root of x2 minus x1 plus y2 minus what? y1. These are subscript, okay. All square. So it means that anytime I am asked to find the distance between a point A and B, C, D, I am only going to locate their coordinate, then subtract the x coordinate together and square them. So already is going to be squared. Then we subtract the coordinate on the y-axis and square them. Find the square root of that. That gives us the perfect solution of what we are looking for. The distance between A and B is going to be this. So the beauty of it is that you can also decide to look out for distance. I'm only saying distance, right? The distance between this and this. Since I am subtracting this from this, I can also subtract 3 from 1 and I'll get negative 2. Only tells me the direction. So here I can also say x1 minus x2. Because of the square, the negative will not matter. Because if this answer becomes negative 2, in the case of this, negative 2 squared will be positive 4. So no need trying to figure out which of the variables come first. The x2 can come first before the x1. The x1 can also be first before the x2. So let's just say we are indicating this point here as what? 2, 1. Then we have the b. Let's have the b to also be 5, 5. Meaning 5 is here, 5 is here. Just like you are seeing 5 here. I extend this to that 5. Here I am having 2 on the x-axis, 1 on the y-axis. If I am asked to find the magnitude, so the magnitude will just be the square root of, after quoting the formula, this is my formula, I'm quoting it. And how will I indicate? The first point is your x1, y1. You can see that first coordinate is the x, second is the y. So this is going to be your x2, y2. So if that is out of the way, what do? We are going to begin with x, right? So x2, which in this case will be 5 minus x1, 2, all squared, y2, 5 minus y1, all squared. After quoting the formula, we can do substitution, right? So fast forward, I can have this to be 3 squared. This will be 4 squared, which will give us 9 plus 16, I guess. That will be root 25 equals to 5 units. I'm adding unit because the distance could be in kilometers or in meters or in miles. So the unit here means whatever unit design in the question could now replace that. So this means that the distance between A and B is nothing but what? 5 units. 5 meters, centimeter, whatever unit assigned to it. And I'm sure at this point, the concept of finding the distance between 2 points on the plane, the magnitude, the modulus of the line or the length of the line is understood by this concept. I guess you get it? Good. If you follow through, share with somebody, leave a comment behind, subscribe if you are new, comment, and let's get interactive. Bye-bye.